bought it. Bought it exactly, okay. Yeah. So here we will substitute this one, z. So I'm writing in here only the z as y by sine theta. Changing the color of the pen. RD can be written as under root of z cos theta. So y cot theta whole square plus d square plus 2dy cot theta into cos phi. Yeah, so that's it. That's the curve that we would get while this moves along, while the rod moves through the plane. Now let's go to the Desmos and tweak some, I don't know, I mean, change theta or phi. Like I will be using phi and alpha. I will substitute one of them with this and the other one with this one. I mean, I will eliminate this theta. I will not write theta because in Desmos, if you write something in function of as a function of x and theta, it directly assumes it to be in a polar coordinate. So that kind of does not give a graph or maybe give a odd graph. So let's go to Desmos. So I've written the exact same equation right here. Suppose I know, but I've changed theta for phi and theta for phi and phi for alpha, as I said, and for d to be some finite number other than 0, it forms a curve for different values of theta and phi, as I explained in the explanation part of the video. And as you see, it forms a curve, not a straight line. Just look at the upper portion of the graph, because the lower portion of the graph, it can represent something, I guess. I'm not sure what it represents, but it is like no, it represents something, but it does not represent what we intend it to be. Like our rod extends in positive y axis, right, along positive y axis, and along positive y x-axis, not negative y x-axis. So let's consider only about this part, not the lower part. Yeah. So so this should be the graph. Nothing much to say in this. One thing that I can show you is like when you tend d to be 0, the curve actually tends to be a straight line, and our intuition sets in. Like I can show you, if I can just look at the upper part of the curve, as I said. So it's a straight line. I take for my words that it is a straight line indeed, with the value of slope being slightly less than 1, as is evident from this increasing area of triangle. I guess, I mean, if it would have been a slope 1 line, then it would have gone like through this, then through this, then through this, through the intersection point only, and it would, I mean, you get the point, right? So why should this be a straight line for d is equal to 0 case? The answer lies like if you fix one of the bases of the rod to be at the center itself, the rod traces a cone, and when you slice a cone through a plane, the plane actually gets a pair of rays to be precise, like from one here and one from one here. And when we look at one of its limbs, we get a straight line, and that's the reason why it's a straight line. And for any other values of d, it actually is a curve indeed. And I think some value of theta alpha, we may get the this is this I don't know this kind of so for some arrangement of alpha and theta, alpha and phi. I think we can also get the curve in question, like the curve right here, I meant. So yeah, that's the video. That's all I can say. And the thing I can also say is thanks. I mean, it doesn't look like thanks, but I mean thanks. So thanks. Bye.